Hi everybody. This podcast is about the first derivative test. In the last two videos, we talked about first how to find the relative extrema in a closed interval. We found the minimum and the maximum within the interval. And the second video was about figuring out the intervals and whether or not the graph was increasing or decreasing within those intervals. Now that you have this information, you're able to tell which way the graph should be moving. We can use the same information to conduct the first derivative test. And what that tells us is whether or not a relative max or a relative min exists within the intervals that we have set based on the increasing and decreasing intervals that you found. So the rules are, once you find the increasing and the decreasing, that if the function's derivative changes from negative to positive, then this is a relative, I'm going to say big arrow, relative minimum. If the derivative changes from positive to negative, then we have a relative maximum. And of course, if there's multiple changes from increasing to decreasing to increasing, etc., you will have that many mins and maxes involved. You can also have a case where there is no, let me get rid of that, where there is no change between intervals. It means there is no min or max. And that is a possibility, though we probably are not going to actually see that too much. I'm going to take this out because it looks like I wrote the word minor. I meant minimum, or maximum. So let's start with an example of this function. We're going to quickly review how we would find the increase and the decrease, and then we will talk about judging whether or not there's a relative min or a relative max. So I have the function f of x equals 2x cubed plus 3x squared minus 12x. So the first thing I have to do is take my derivative. So I get 6x squared plus 6x minus 12. I need to factor that. So I get a 6 x squared plus x minus 2. And this factors to 6, x plus 2, x minus 1. Okay, so that gives me critical numbers of x equals negative 2 and x equals positive 1. Okay, I'm going to use my critical numbers to make my intervals. Remember, this is a continuous function, so it starts at negative infinity. It goes to negative 2, from negative 2 to positive 1, and then from positive 1 to positive infinity. These are the three intervals that we're going to test. So the first time we tried something like this, where we used critical numbers and we tested it, that was on a closed interval. On a closed interval, you would check it or test it in the regular function. But because this is an open interval, we're testing it in the derivative. So I'm going to just pick some numbers here within the function intervals, and I will substitute them in. I'm not going to work out the math for you. I'm just going to say that this is what they are. I have worked out the math. The answer to this is 24. This is negative 12. And this is positive 60. So I have a positive number here. I have a negative number here. And I have a positive number here. And so positives mean that the graph is increasing. Negatives mean that the graph is decreasing. And this, again, is increasing. So we have figured out the shape of our graph by saying it's going to increase, decrease, increase. That should make sense to us. This is a cubic function. So now the next step is to apply the first derivative rule. And you'll remember it says when the function goes from a positive to a negative number, this is a relative max, right? This is a relative max at negative 2. When I plug negative 2 into the actual function, which is what we would have to do to graph it, I get 20. So I'm going to put a little note here. Okay, to plug into the function. Okay, and now let's take a look over here at the next joining of the intervals, and that is going from a decrease to an increase. And we said that would mean that this is a min. Okay, the min is at x equals positive 1. When I substitute that into the function, I get negative 7. So the cubic function 2x cubed plus 3x squared minus 12x has an increasing graph between negative infinity to negative 2, a decreasing graph from negative 2 to positive 1, and an increasing graph from positive 1 to positive infinity. So let's take a look at one more function. We have f of x equals x squared times the difference of 3 and x. Excuse me. So in order to be able to take the derivative of this, we have to distribute this back out. So I'm going to change this into 3x squared minus x to the third. So I'm going to take the derivative of that, which would be 6x minus 3 minus 3x squared. I'm actually going to rewrite that to negative 3x squared plus 6x, so it's in order. So I got to factor that. I'm going to take out the negative 3x, and that will leave me with an x minus 2, right? Because negative and negative will give me this positive over here. Okay, so if I want to find my critical numbers from negative 3x, x equals 0, and from x minus 2, x will equal positive 2. That's because I set each of these terms equal to 0 and then solved. Okay, so now I have my critical numbers, and I'm going to quickly make my intervals. Remember again, continuous function, and so negative infinity and positive infinity are involved. So negative infinity to 0 0 to positive 2, and 2 to positive infinity. Okay, so when I test the derivative of the function with -1, I get -3. When I test the derivative with +1, I get a +3. And when I test the derivative with, oops, I put an X in there, doesn't belong. Oh boy, now I gotta fix all this mess. The derivative of +3, I get -9. So I have a negative sign, a positive sign, and a negative sign. So that means this is decreasing, increasing, and then decreasing again. Okay, so I want to just point out to you, when we report this, we're actually going to say decreasing on the interval of -infinity to 0, increasing on the interval from 0 to 2, and then decreasing again on the interval from 2 to positive infinity. And remember, this is continuous, so all of these, the notation, are done with parentheses. Okay, the last thing I'm going to do is check for a relative min or max. So between the first two intervals, I have a decrease to an increase. So that actually is giving me a relative min. Okay, and we're calling it a relative min. And that is at the point 0, right? Because that's the critical number in this position. And so when I plug 0 into my original function, I get 0 as my y value. Okay, this is going from increase to decrease, so this is becoming a relative max. So this is a maximum. And it's happening at when x equals 2, because that's my critical number here. And when I plug 2 into the original problem, I get 0 also. So I take that back. I didn't get 0. 2 into the original problem would give me 4, 12 minus 8, which would be 4. Sorry about that. Okay, so let's review this again. The function of x squared times the difference of 3 and x has been, I have taken the derivative of it, the first derivative. I've found the critical numbers of 0 and 2. I set up 3 intervals, -infinity to 0, 0 to 2, and 2 to positive infinity. I tested numbers within those intervals in the derivative, and I found the behavior to be decreasing, increasing, and decreasing respectively in that order. I noted the intervals of the decrease at -infinity to 0 and also +2 to positive infinity. I noted an increase in the interval of 0 to 2. At 0, at 0, 0, there is a relative minimum, and at 2, 4, there is a relative maximum. And this is what we call the first derivative test, this part right here, the relative min and the relative max. Okay, that's it for now.